So now on to part two of Lewis structures and bonding. So if we took a molecule like NaCl, now I think that everyone would be able to classify this simply from early on in the class whenever we were talking about organization of the periodic table. You'd be able to see that sodium is a metal and chlorine is a nonmetal. So that's a pairing of a metal and a non-metal. Okay, so those two things combine to make an ionic compound. Now, whenever we're talking about this from the vantage point of bonding, one of the things that we need to be asking ourselves is, well, where are those electrons? And how many electrons are we actually talking about? So we could see something like, how many valence electrons does a sodium atom have? Sodium atoms are in group 1 of the periodic table, so they have 1 valence electron. How many valence electrons does a chlorine atom have? A chlorine atom is in group 7 of the periodic table, so it has 7 valence electrons. Now how does the number of valence electrons play out for something like NaCl? So let's go ahead and imagine that we're drawing the Lewis structure for a sodium atom and the Lewis structure for a chlorine atom. So what we're going to do is we're going to place these electrons around our symbol for those individual atoms. So we've got 1 valence electron for sodium and 7 valence electrons for chlorine. Now, what you see happen is this single electron over here gets transferred over here. And whenever that happens, what do we have? Now we have Na, which is a cation, and Cl, which is an anion, because its overall charge is -1. But let's think about the electronic composition. So all of my original 7 valence electrons from chlorine are indicated in red, and my 1 valence electron that got bumped over to chlorine is highlighted in blue. So an ionic compound for a Lewis structure is going to look something like that, where you're identifying those two individual atoms and they are separate from one another. Now, covalent bonding is a little bit different. The nuclei of those two atoms, they are going to be close to or relatively close to one another because you are sharing electrons. Now, what we see here in this top figure, this one right here, is we're seeing the nuclei of our two individual atoms. So let's just call this atom, let's just, for the sake of an example, let's say CH4. CH4 is a compound made up of nothing but nonmetals, carbon and hydrogen. So this is what the carbon nuclei is doing and the hydrogen nuclei. They are relatively close to one another, but they are repelling one another because each nuclei is positively charged. Now there are electrons being shared between those, and those electrons, they are both attracted to the nucleus, but they are also repelling one another. And so what we get from that is this diagram down here. This again shows our carbon nuclei and our hydrogen nuclei, but all of these dots, all of those individual dots are probabilities or probable electron locations. And the electrons that are being shared between this carbon and this hydrogen, the two electrons, could be in any one of these places because, keep in mind, they've got a number of forces. Those electrons are attracted to the nuclei, but they are repelling one another. They are opposed to being around one another. So that brings us to another discussion, or a discussion of something like hydrogen, H2, hydrogen gas. Well, in this case, each hydrogen atom, well, they are both in group number 1. Now, hydrogen is an exception to the rule because what does hydrogen want to do? Hydrogen wants to have a total of 2 electrons surrounding it. Now, if you took this 1 electron from this hydrogen atom and threw it on the other one, then you've got 1 hydrogen with 2 electrons and then 1 hydrogen that's going to be positively charged, and that's not what we have. When we're talking about something like H2, what we have is a sharing of electrons. So actually, I'm going to change color. This one of them, I'm going to write in blue. It brings its electron, and the other hydrogen atom brings its electron as well. So each one of these, I'm going to circle them in different colors, or highlight them in different colors. this hydrogen, as far as is concerned, it sees, well, 2 electrons. Then, if we look at this hydrogen, it also sees 2 electrons. Those electrons are being shared between those 2 hydrogens equally. And there we go. There's another depiction. Yeah, I said all that. So a single bond is characterized by the sharing of 2 electrons. Now, what we'll also see from time to time are multiple bond situations. So if we took something like, you know, your sort of run-of-the-mill simple representation is going to be CH4, which these are all single bonds. But then you might have something like H2CO, in which case this is a molecule that's going to look like such. And finally, so this would be a double bond. I'm going to write 2x bond. But then our last example would be a triple bond. And these are not super common, but they're worth noting. And one example would be something like N2. That's an example of a molecule with a triple bond. All right, I hope this was helpful. We're going to get into drawing some individual molecules and going through the process of drawing the Lewis structure of different molecules in just a little bit.